Good morning. Good morning. Good morning. Everybody good? Okay. So vector is started, unit dimension is started. Last class, unit dimension, I started the dimension. I said the dimension of some physical quantity, I said. And that I said you have to remember also, because some dimension means if you remember, then it will save your time to solve the problem. So last dimension, what I said, anybody will say? Permittivity, good. So I said the permittivity dimension, and for the permittivity, easiest formula is what we will use. There is no need to mug up the permittivity because maybe you can get confused. So easier formula is Coulomb's law. By the Coulomb's law, we can easily get the dimension of the permittivity. Okay. Next one is the what? Permeability. Permeability, one problem is what? When later in the magnetism you will learn the permeability. So permeability will never, like any formula is not there, in that only permeability is unknown. Permeability will either come with a self-inductance or it will come with a magnetic induction, magnetic field. So what will happen? First you have to find their dimension, then you can find the permeability dimension. So it will take time. So permittivity, Coulomb's law, because we know the dimension of the F, we know the dimension of the charge, we know the dimension of length. Okay, by that we can find the permittivity. If we require the permeability, what we will do? Okay, then in the optics, in the EM wave, I said I will say this formula C, and maybe you know also, 1 by under root of mu naught into epsilon naught. Means speed of light in the vacuum, we can say C is equal to 1 upon under root of mu naught into epsilon naught, where mu naught is the permeability of the vacuum and epsilon naught is the permittivity. Okay. Now C is what? Speed. Speed dimension is what? LT minus 1. C, and epsilon per dimension we already got. Then by using this, I can say what? Mu naught. If you square on both sides, so C square is equal to 1 upon mu naught into epsilon naught. Then dimension of mu naught. What I can say? Dimension of 1 by C square into epsilon naught. Now C square dimension is what? C dimension is the LT minus 1. Ultimately it is a speed only. LT minus 1 whole square, and epsilon you got in the last class. Okay. So what is the dimension of epsilon? Then you will get what? 1 upon L square T minus 2. Anybody will say permittivity dimension? So ML2 T minus 2 is equal to 1 upon epsilon into A square T square by L square. L will get cross multiplied, so epsilon what you will get? M minus 1 M minus 1 L minus 4 ML2 L minus 3 M minus 1 L minus 3 ML, then L minus 3, then here T to the power 4 A square. M minus 1 M minus 1 L minus 3 T to the power 4 A square. That is the dimension of epsilon. Now you can put here M minus 1 L minus 3 T to the power 4 A square. Now shift this in the numerator, you will get the dimension of mu naught. Completed? Okay, so by this way we can get the dimension of the mu naught, because for the mu naught separately you are writing any other formula and then in that you are finding the other unknown, then it will take time. So this is the way that we can find the mu dimension. Okay, everybody got? Then what is the dimension? M minus 1, then it will be the M. L2, L minus 3, L minus 1 remaining, so L. Then T minus 2, T4, then you will get the T square means T minus 2. And then here A minus 2. Everybody got? So that's why I'm saying very like few dimension we will only remember, because like that way power and everything we cannot remember. If you are mugging, then you will get confused in the exam. So it is better that we have to know how to find the dimension. Okay, completed? Okay. Okay, next thing, like gravitation potential and electric potential dimension I said. Like suppose I need the gravitation potential. This also no need to mug up. Anybody will say, what is the formula of the gravitation potential? Formula of gravitation potential. Formula of gravitation potential. Formula of gravitation potential. Gm minus Gm by R, minus sign for the dimension, minus sign doesn't matter. But if suppose you are using the Gm by R, okay. Similarly, electrostatic potential is what? Electric potential is what? 1 by 4 pi epsilon naught into Q by R. Okay. So if you are using these formula, then like when you are using gravitation potential Gm by R, then you have to know the G dimension, capital G dimension. I said you have to remember, but you have to know. Then you can find the gravitation potential. If I'm saying what is the dimension of electric potential, electrostatic potential, then you have to know 1 by 4 pi epsilon naught into Q by R. So epsilon naught means permittivity dimension you have to know. So first you will find permittivity, then you will find electric potential. So for the dimension always we will try to remember the basic formula so that easily we can get the dimension. Okay. So later you will learn in the gravitation, maybe you know also, like gravitation potential we are defining the work done per unit mass. In detail, what is the definition that I will discuss later. But gravitation potential, I can say work done per unit mass means W by M. And in the electric potential, it is a W by Q. Why I am using this formula? W is the work done dimension we know, and charge and mass dimension we know. So it is the easiest method to get the dimension of the electric potential or gravitation potential. In the 2022, even they asked the gravitation potential dimension. Then Vg, what I can say, W by M. This is the simplest formula for the gravitation potential from which you can find that dimension. Okay. Now I can get the dimension. The dimension of Vg. Work done is what? ML2 T minus 2 and upon M. MM cancel out, what you got? L2 T minus 2. Everybody got or not? It is the easiest way to get the dimension of the gravitation potential. If I am saying electrostatic potential, then for electric potential we will use what? W by Q. W by Q. Now W dimension is what? Same, that is a ML square T minus 2. Q is what? Charge. Charge dimension is what? AT. Then what you got? M L square T minus 3 A minus 1. That is the dimension of the electric potential. So if you are going through the 1 by 4 pi epsilon into Q by R, it will be complicated. Okay. Everybody got? Okay. Similarly, suppose I am asking what is the dimension of the electric resistance R. So we know the Ohm's law, V is equal to IR. So R is equal to V by I. Okay, V I can find from this, and the I is what? Fundamental. Everybody getting? So when resistance I am asking, electric resistance, so R is equal to V by I. V upon I. What is I? A. So then A minus 2 you will get in this. Okay. One question came in the J main, a little bit different, but suppose I am saying dimension of under root epsilon by mu. We have to find the dimension of under root of epsilon by mu. Okay. Then how you will find? One way is what? Find the dimension of epsilon, find the dimension of mu, and then you can get the dimension and divide both. You will get the dimension of epsilon by mu. Okay, but it will be lengthy because epsilon also you have to find, mu also you have to find, and then you have to divide. Okay, so when you see the both epsilon and mu together, then which formula has to come in the mind? Which formula will come in the mind? If both are there, so which formula will come? Just now what I said, C is equal to 1 upon under root of mu into epsilon. C is equal to 1 upon under root of mu into epsilon. Okay. So if I will get the mu and epsilon, then I can replace by C. Then what I will do? Multiply with epsilon and divide with epsilon. No change. When I multiply, then I divide also. So equation remains same. Now epsilon, epsilon, epsilon square. Root is there, then you can write as a epsilon. Okay. And 1 upon under root mu into epsilon. 1 upon under roots. This formula just now I said. C upon under root of mu into epsilon. So 1 upon under root mu into epsilon, what I can write? C. So this I can replace by C. Okay. Now you got C into epsilon. C dimension you know, epsilon dimension you can find, and you will get the dimension of the under root of mu by epsilon. Everybody understood or not? So means we have to save the time also in the exam. So we have to go through the best way, means which will save your time. So they are using the combination of the different quantity. If you start finding the dimension of all and then you will solve, it will take so much time. So just think about how I can go through the simple way. Completed? Now after that you will find now that epsilon dimension already written, C dimension is LT minus 1. Okay. If I am saying what is the dimension of d2p by dx2, where p is the pressure, p is the pressure. So double differentiation, what is the meaning of differentiation? Double differentiation, Akhilesh sir said in the basic mathematics. So how we will find the dimension of d2p by dx2? We have to find the dimension of d2p by dx2. Now listen. What is the meaning of differentiation? Like double differentiation. So double differentiation means you are differentiating with respect to s, twice. Okay. Like velocity. What is the velocity? I can write v is equal to dx by dt. V is equal to dx by dt. And what is the acceleration? A is equal to dv by dt. A is equal to dv by dt. That is the acceleration, and velocity is what? V is equal to dx by dt. If you are differentiating the x, like x you differentiate, velocity you got, velocity you differentiate, acceleration you got. So it means what? X you have to differentiate twice, then you will get acceleration. So later you will learn A is the d2x by dt2. So that is the meaning of double differentiation, means when we are differentiating twice. So this d2p by dx2, what I can write? d2p by dx2, that is equal to what? D upon dx of dp by dx, means it is a double difference, like dv by dt, so v what I write? Dx by dt. Same way, what is the meaning of double differentiation? D upon dx of dp by dx. It is the first differentiation, it is the second differentiation. Everybody got the meaning of this or not? In the basic mathematics you have learned also. So what is the dimension? Now dp by dx, d upon dx, d upon dx, dp by dx. One thing I said, change in the quantity and the quantity has the same dimension. Change in the quantity and the quantity has the same dimension means dp, like velocity minus velocity, you will get velocity. Last class I discussed this also. So dp means delta p, change in pressure. It will have same dimension as pressure. Okay. Dx, it will have the same dimension as x. So then what I can say here, dp has the dimension of pressure. Delta of delta, delta of delta, ultimately delta. So means numerator is what? Delta of delta p. Delta of delta p means ultimately it is a pressure. Pressure dimension everybody know. Are everybody getting or not? So the delta of delta p, like this you can think. Delta of delta p, ultimately what I will get? Pressure only. Okay. So numerator is the pressure. And pressure dimension is what? Pressure is the force upon area. Force I can say ml, t minus 2 upon area is what? L square. Then you will get. Already I said this and I think you remember also. ml minus 1, t minus 2. So numerator dimension I got what? ml minus 1, t minus 2. It will be the dimension of pressure. Now see the denominator. Denominator is what? Here dx. Dx means what? Delta x. Delta x will have same dimension as x. So then what you got? L. And here also dx. Dx has same dimension as L. Then you will get what? L. Now L square is there. Then it will go up. Then m L minus 3 t minus 2. M L minus 3 t minus 2. That is the answer. Okay. Okay. So these are the basic dimension that everybody has to remember. Okay. Slowly means capital G and all you will remember. Up to this and rest whatever I am not going to discuss all dimension now because so many formula you don't know. So as you will learn the physics different chapter, when you are learning the new quantity, you will find the dimension of those quantity. Everybody got or not? And some problem, some particular type of problem that I will discuss in the revision time because that time you know the whole physics formula. Okay. So right now I am not discussing that. Okay. Completed. Now some points that we have to know about the dimension. One thing is what? We know that different physical quantity may have same dimension. Like they are representing the different quantity, but their dimension are same. Like work, torque. Work and torque. Work dimension ml2 t minus 2. Torque is what? R cross F. Torque is what? R cross F. R cross F dimension is what? ml2 t minus 2. So there are so many like physical quantities means they are the different physical quantity but their dimension are same. Like force constant of a spring. Force constant of a spring, you know the formula F is equal to kx. From that you will find the dimension of k, you will get mt minus 2. Mt minus 2. Same way if you are saying the surface tension. So surface tension basic formula I can say F by L. F by L. Then dimension what you will get? Mt minus 2. So many physical quantities are there. They are the different physical quantity but they have same dimension. Okay. So we can say what? Different physical quantity may have same dimension. Okay. Example already I said. Completed. Next thing is what? There are some quantities they don't have they are the physical quantity, they are not the numeric constant. I said pure number does not have unit or dimension, like number 5 does not have unit or dimension, but physical constant has dimension, like capital G value, its value is constant, 6.67 into 10 to the power minus 11, but it is not the number, it is not the numeric constant, it represents the physical constant, so it has a dimension, it has a unit also. Okay, so but some quantities are there, they don't have the unit as well as dimension. Okay, like strain is a physical quantity, but it does not have dimension, like strain is the change in length upon original length upon length, no dimension. Okay, so when you are dividing the two same quantity, you are dividing the two same units, then what we can say, ultimate result will be unitless, result will be dimensionless. When we are dividing same units, then we can say result will be dimensionless. Okay, so strain delta L by L or delta V by V, change in volume upon original volume, it is a dimensionless. Okay, similarly angle also you can say it is a dimensionless, angle is the arc upon radius, L upon L, dimensionless, but I'm not saying the unit, angle has a unit. So some quantities are there which does not have unit as well as dimension. So example is what? Strain does not have unit, does not have dimension. Next one, refractive index. What is a refractive index? Later you will learn in the optics. Refractive index is the ratio of the speed of light in vacuum upon speed of light in any medium. So like C by V, it is a ratio of the two velocities. So refractive index is the dimensionless as well as unitless. Next one, relative density. Relative density is what? Density of substance upon density of water. Density upon density, unitless and dimensionless. So there are so many physical quantity, we can say they are the unitless as well as dimensionless. Coefficient of friction, yes. So some physical quantities does not have unit as well as dimension. Okay, example already I said, refractive index, refraction, relative density, strain, friction coefficient, etc. Okay, completed. But like two quantity mainly that we know, means a quantity does not have a dimension but it has a unit. A quantity does not have dimension but it has a unit. What is that example? So many times I said a quantity does not have dimension but it has unit. A quantity does not have dimension but it has unit. Solid angle and plane angle, good. So some quantities we can say have unit but no dimension. Example is what? Plane angle and solid angle. So plane angle has a unit radian, solid angle has a unit steradian, but they don't have the dimension because plane angle is what? Arc upon radius. Arc is the dimension is what? L. Radius dimension is what? L. So L upon L, no dimension. Similarly, solid angle, area upon R square. Area dimension is what? L square. R square dimension is what? L square. So they will be dimensionless, but they have the unit. Anybody can say any example In that case, dimension is there but unit is not there. Any physical quantity you know where the dimension is there but no unit. Any example you have where the dimension is there but it does not have unit? Any example? Anybody will say? It has dimension but no unit. It has dimension but no unit. It has dimension but no unit. Anybody has example? It has dimension but no unit. Anybody has example? No. So there is no any quantity, because if the dimension is there, so dimension, like suppose dimension is there means either the M will be there, L will be there, T will be there, current will be there. So what will happen? If the any quantity is there, their unit will be there. Like suppose M and mass and permittivity. Wow, permittivity has the dimension but no unit. Nalayak. If suppose you are writing the dimension, suppose I am writing MA minus 2, something like that. So if I am writing the MA minus 2, then M is what? Mass is what? kg, A is what? Ampere. Then definitely you will get the unit. So there is no any example we can say where the dimension is there, unit is not there. If dimension is there, that dimension I can write in the terms of unit, like ml minus 2. So I can say kg per meter square. Everybody getting or not? So there is no example that it has the dimension but no unit. Everybody got? Okay. So can we divide different physical quantity, or we can multiply the different physical quantity? Can we divide the different physical quantity and multiply the different physical quantity? Yes or no? Can we divide the different physical quantity or multiply the different physical quantity? Yes. So means division for the different physical quantity and multiplication is possible. Like velocity we are writing as a meter per second. So meter and second we are dividing, both are the different quantities. So multiplication and division is possible for any, like either like same quantity when you are dividing, then the quantity will be dimensionless. Okay. Different quantity we can divide and multiply. Everybody got? So when you are dividing the same quantity, then we can say what, like meter per second upon meter per second. Then what you will get? Number one thing here, we will not talk about the magnitude. I'm talking about the dimension. So like suppose I'm saying 5 meter per second upon 2 meter per second. So the value is the 5/3. Value is the 5/3. But ultimately the unit will be what? The quantity will be unitless. Okay. So when you are dividing the same unit, then unit will get cancel out. Ultimately we will get the what? Numeric number only, numeric constant. So it will not have any dimension. So we can divide the different physical quantity. We can multiply the different physical quantity. Okay, when we are dividing the same unit, then result will be what? Unitless quantity. Everybody got or not? Here you can write same dimension quantities. Completed. Next one is the principle of homogeneity. What is the principle of homogeneity? So we can only add, subtract or equate those quantity only which has the same dimension. I repeat the statement again. We can add, subtract or equate only those quantity which has the same dimension. Why? Like suppose if I'm saying 2 kg plus 5 meter, how much? 2 kg plus 5 meter, can we add? 2 kg plus 5 meter, we cannot add. Like 2 kg plus 5 kg, I can say 7 kg. Okay. So what I said, what is the principle of homogeneity? Principle of homogeneity is what? We can add, subtract or equate only those quantity which has the same dimension. This everybody got or not? So one, you are equating the two quantity. Like suppose I am saying quantity A is equal to B. It means dimension of A must be equal to dimension of B. So what I said, two quantities can be added, subtracted or equated only when they will have the same dimension. This everybody got? That is the principle of homogeneity. Two quantities can be added, subtracted or equated when they have same dimension. Okay, this everybody got or not? So that is called the principle of homogeneity. Now if one thing I am asking, suppose I am saying the reverse, two quantities have the same dimension. Can we add them always? Two quantities have same dimension. Can we add them always? Reverse statement I am saying. Two quantities have same dimension. Can we add them always? Two quantities have same dimension. Can we add them always? Yes. Okay. Yes, sir. No, sir. Yes, sir. Yes, sir. No, listen. Just now, first point, just remember that different physical quantity can have same dimension. Can I add the spring constant with the surface tension? Can I add spring constant with the surface tension? Can I add the friction coefficient with the refractive index? Can I add the, there is a meaning? No. Everybody getting or not? So that is a necessary condition, means when we are adding the two quantities. So necessary condition is what? We have, because we don't know what are the quantities, but what is the necessary condition we will check? Their dimension must be same. But if I am saying the reverse, if dimension is same, can we add them always? No, it is not necessary. Why? Because different physical quantity can have same dimension. So basically homogeneity is what? Only we can add the same quantities. What is the meaning of homogeneity? Only we can add the same quantity. But we cannot like these quantity are the same or not when we don't know. So what we will check? Necessary condition we have to check what? Their dimension has to be same. But if I am saying the reverse, dimension is same, can we add them always? So not necessary. Why? Because different physical quantity can have same dimension. So basically we can add only same quantities. This everybody got or not? Like suppose this formula everybody know, S is equal to ut plus half at square. Okay. So here what we are doing, we are adding UT and AT square. Half doesn't matter, half is the constant. So UT is the one quantity, AT square is the one quantity I am adding. Okay. So one thing, what I can say, UT and AT square, they should represent the same quantity. So UT is the distance, AT square also it will give the distance. Okay. So and UT dimension must be same as the AT square dimension, must be same as the S dimension, that we can say. Everybody got or not? So dimension of UT must be equal to, if I am writing this relation, then what, from the homogeneity what I can say, dimension of UT must be dimension of the AT square and it will be equal to the dimension of S. Everybody got? Completed? So this is the principle of, so division and multiplication is possible for any quantity, different physical quantities we can multiply or divide. But addition, subtraction and equation, that we can do only for the same quantity we can say, or which quantity has the same dimension. Okay. So necessary condition is what? We have to check what? Their dimension has to be same. Okay. So some example we will do. So suppose I gave the energy, I have written what? Energy is equal to AT plus B upon C plus T. Then among the given option, I am saying which option representing the time? Which option represent the time? Tell fast. Which option represent the time? So one thing from the homogeneity, what I can say, dimension of AT, one quantity, and these two quantity we are adding. So dimension of AT must be same as the dimension of this quantity. Okay. And it must be equal to the energy dimension. And energy dimension we know that ml2t minus 2. Okay. One thing. Second thing, who will say what is the dimension of C? What is the dimension of C? What is the dimension of C? Dimension of C. It is the easiest dimension that we can find. Dimension of C is what? T. Why? If you see the denominator C plus T, I am adding the C and T. We can add only the quantity when they have the same dimension. It means the dimension. Here we are not dealing with the magnitude. Maybe C is the 3 second, time is the anything. I'm not talking about the magnitude. But T plus T, what I will get? Time plus time, what I will get? If I'm saying T plus T, what I will get? T only. Don't say 2T, sir. Magnitude we are not dealing. We are dealing with a unit or dimension. So time plus time, time. So what is the dimension of C? Time. Okay, so we can say dimension of C is equal to T. One thing. Now from the homogeneity, what I can say? Dimension of AT is equal to dimension of B upon T. Everybody understood what is the meaning of B upon T? Why I am writing B upon T? Because it is about B upon C plus T. And C plus T, what is the dimension? T dimension. Okay, so directly denominator dimension, what I can write? T. Here I have written what? B upon C plus T. C plus T, what is the dimension? T. So in the terms of dimension, what I can write? It is the B upon T. So that's why I'm saying dimension of AT is equal to dimension of B upon T. This everybody got or not? C plus T is there, but C plus T dimension is what? T dimension. That is equal to dimension of energy. Okay. If I'm solving this one, then dimension of AT means dimension of A into dimension of T. What is the dimension of T? T. That is equal to dimension of energy is what? ML2T minus 2. Now T will come down, then what you will get? ML2T minus 3. It is the dimension of A. Everybody got? Okay. Similarly, dimension of B, how I can find? So dimension of B upon T, dimension of B upon dimension of T is what? T. That is equal to what? Dimension of energy, dimension of energy. And energy dimension is what? ML2 T minus 2. Now cross multiplying, then what you will get? Dimension of B is equal to ML square T minus. So dimension of B, what I got? ML square T minus 1. Now you have the dimension of A and B. If you see the A and B, so A and B both contain ML square. Okay. I need time. I need dimension of time. So how I can eliminate the M and L? If I divide both. If I divide both, M and cancel out, LL cancel out. Okay. Now, if I am dividing A by B, then I will get T minus 3 upon T minus 1. That is what? T minus 2. But what I need T, so I have to divide reverse. Reverse means B by A. If you are doing the B by A, you will get T square. But I need the time, so I have to take the root, then I will get T. Then what is the answer? Under root of B by A, option 4. Everybody got? So B by A, what you will get? T square. Now, root B by A, what I will get? Root B by A is equal to T. Completed? Okay. In 2024 NEET, this question they ask, force F alpha T plus beta T square, then which quantity is dimensionless? Like this option was there. So I gave the force F is equal to alpha T plus beta T square, and I'm asking which quantity among the given option, which quantity is the dimensionless. Then what you will do first? Who will say? What to solve this problem? What you will do first? What you will do first? So somebody will say, sir, what we will do? Dimension of alpha T must be equal to dimension of, we will use the homogeneity. Dimension of alpha T is equal to dimension of beta T square is equal to dimension of F. Okay, then alpha T F, then you will get the dimension of alpha. Beta T square, you will equate with the dimension of F, you will get beta. After that, we will check the option by dividing alpha by beta, alpha T by beta. Everybody getting or not? Maybe this thought will come in the mind. Okay. without finding any dimension, we can get the answer. Without finding any dimension. How? If you are using the principle of homogeneity, then we can say what? Alpha t and beta t square. Alpha t and beta t square has the same dimension. Alpha t, by the homogeneity, I can say what? Alpha t, dimension of alpha t is equal to dimension of beta t square. Dimensionally both has to be equal, same. Okay. If I am dividing the two quantity of same dimension, if I divide the two quantities of same dimension, what I will get? Dimensionless. If I am dividing two quantity of same dimension, then I will get dimensionless. So these two quantity, beta t square and alpha t, they have the same dimension. So if I divide them, I will get dimensionless. Then how I can divide? I have the two options, either alpha t upon beta t square, or I can say beta t square upon alpha t. Ultimately both will be dimensionless. Okay, then 1t cancel out. What you got? Alpha by beta t is dimensionless. And everybody got or not? Okay, if option they given beta t by alpha, then also we can say it is a dimensionless. Are everybody got or not? So no need to find the dimension of alpha and beta. Directly we can say the dimensionless quantity. Okay. This completed. Everybody know the real gas equation in the chemistry. You learned van der Waals equation. It is what? Suppose for the 1 mole I am writing P plus A by V square into V minus B is equal to RT. Okay, this is a van der Waals equation. Okay, I am asking here, tell fast, where P is the pressure, V is the volume. If P is the pressure, V is the volume, then what is the dimension? P is the pressure, V is the volume. Tell fast, what is the dimension? Fourth option, one answer we got. Now listen here. Again the same homogeneity we have to use. Dimension of P is equal to, I am adding whatever is the equation, doesn't matter. Here P I am adding with A by V square, where V is the volume. Okay, so dimension of P should be same as dimension of A by V square. Okay, A and B are the van der Waals constant, and here I am subtracting the B from volume, so it means dimension of B must be same as volume. Okay, so from this first we have to find the dimension of A and B. Okay, so I can say what? Dimension of, from the homogeneity, A by V square is equal to what? Dimension of pressure. Okay, now what is the pressure dimension? Pressure dimension is what? M L minus 1 T minus 2, force upon area. Then this I can say what? Dimension of A upon V square. V is the volume. Volume dimension is what? L cube. L cube square means what you will get? L to the power 6. Now cross multiplying, then what is the dimension of A you will get? Dimension of A is equal to what? M L5 T minus 2. This is the dimension of A I got. Similarly, I can say dimension of B. Dimension of B is what? Dimension of volume. Dimension of volume. Why? I am subtracting the B from the V. Now volume dimension is what? L cube. You got that A and B dimension. Now what is the energy dimension? ml square T minus 2. So answer is A by B. So A by B is equal to ML2 dimension of ml square T minus 2. So it represents the energy dimension. Everybody got? So answer is fourth one. Completed? Okay. So these are the based on the homogeneity. One last problem. It is a very common problem. So many places you will see. If P, Q, and R are three different physical quantity, then which option will never meaningful? Tell fast. PQR are the three different physical quantities. So among the given option, which will never meaningful? Four. Everybody is saying the answer 4. 2, 3, 4. Wow. So one thing which will never, I'm saying, which may be, that is I'm not saying, which will never. So which will, if suppose here, second option, division multiplication is possible for any physical quantity, that everybody know. Okay. So first one, here I can say what? This is possible. Second one, P by R plus Q. So P upon R, P is different, R is different, but it is possible that P upon R will be same as Q. P upon R will be same as, it is possible. Okay. If I'm directly adding, then directly I'm adding the different quantity. But what I'm adding here, I'm adding P by R with Q. Okay. So one example I will give. Suppose I'm taking the three quantity L, V and T. L, V and T. Okay. So if I'm taking the P as a L, P as a L, R as a T. P as a L, R as a T. Then what I will get? Yeah, that is okay. So Q is the V. Q is the V. P is the L and R is the T. So P by R, what I will get? L by T. L by T is what? Velocity, LT minus 1. And Q is what? Velocity. So these three are different, but their summation is what? P by R is the LT minus 1. Q is what? Also LT minus 1. So it is possible. Not always, but possible. Same way, third also we can say. PQR are different, but it is possible that PQ is same as R. So it is possible. Same example. If I am taking the P and Q is the V and T. PQ is the V and T. Okay. And R is the L. So P into Q, what I will get? Vt. Velocity into time is what? Displacement. That is what? L plus L I can do. So it is a possible, not always, but possible. But directly different physical quantity I cannot add. That's why this will never be meaningful. So answer is what? Fourth one. Everybody got? Okay. Completed? Up to this okay? So this is the principle of homogeneity. Okay. Now another type of problem is what? In the unit dimension, what they ask? They change the fundamental system. They change the fundamental system and then they ask like what is the dimension of this quantity? What is the dimension of this quantity? Like we know our fundamental system like M, L, T and the other 4 quantities. Okay. But they are saying take these quantity as fundamental and then you have to find the dimension of the mass. Then it is possible that mass will be derived, length will be derived. Okay. So they are changing the fundamental. Fourth may have what? 4 may have same. No, why same dimension? If suppose they have the what I said in the problem, P, Q, R are 3 different physical quantity. Can you add? Even dimension are also same. Can you add 2 different physical quantity? Who is asking this doubt? 4 may have same dimension. So they are the different physical. We know that different physical quantity can have same dimension. Yes, that is okay. But one more thing I said, na. It is not necessary that dimension are same, then we can add them always, because the different physical quantity can have same dimension. Okay, so here I mentioned in the problem P, Q, R are the 3 different physical quantity and 3 different physical quantities we can never add. Understood or not? Okay, so now that type of problem I am discussing. If energy capital E, velocity V and time T are taken as fundamental, then find dimension of mass. Okay. If energy E, we know that in our actual fundamental system, energy is the what? Derived quantity. Velocity is the derived quantity. But I am take energy, velocity and time as fundamental. Then what will happen? Then they are saying mass is derived. Then what is the dimension of the mass we have to find? Then we have to find the dimension of mass. Completed. Okay, now in this type of problem, in the JEE Mains, so many times they ask this similar question. In the NEET also 2 times they ask this concept based question. So one first method, what I'm saying, it will take maybe within 5 seconds you will get the answer. Okay, but for this means you have to read the question properly and you have to relate the quantities. Okay, like. So first method is not a method. It depends upon you. If it click in the mind, then you can get the answer within 5 seconds. Okay. Like here what I'm saying energy, velocity and time I'm taking as fundamental. And then I'm saying what is the dimension of mass. Okay. So when energy I'm talking about, so any energy, whether kinetic or potential, energy is energy. Okay. So energy, velocity and time I'm taking fundamental. Mass I required. So mass, energy, velocity, if these 3 are there, which formula will come in your mind? energy, velocity and mass, if these three quantities are there, which formula will come in the mind? Energy, velocity and half, very good. K is equal to half mv square. So means if I am writing the energy, kinetic energy, what? Energy is equal to what? Half mv square. Okay. Then now E is the fundamental, V is the fundamental. Okay. Then what is the dimension of M? Dimension of M, I can say what? E by V square, or I can say what? E V minus 2. Now E is fundamental, V is fundamental, then what is the answer you got? EV minus 2. Okay, so means without finding anything, without finding any dimension, directly you got the, because ultimately mass I have to write in the terms of fundamental quantities. What are the fundamental? EVT. Okay, then directly I am able to write the mass in the terms of E and V. Time dimension is what? 0. Okay, so T to the power 0 we can write. So what is the dimension of mass in this new system? EV to the power minus 2. Everybody understood or not? Okay. Say yes or no. Okay, so this is the one way that we can get this. Okay, directly if you are able to relate the given quantity, any formula, it click in the mind, then within 5 seconds you can get the answer. Okay, up to this. Okay, okay. Now second method. What is the second method? Suppose it does not click in the mind, but at least you have to get the answer. So I will say the two methods. By using that, you will definitely get the answer. So second method, what I am saying, which derived quantity, they are saying take as fundamental. Like here they are saying energy and velocity. Both are the derived, that we know. In our fundamental system, energy and velocity is the derived. So, but that they are saying fundamental. So what they are saying fundamental, first write their actual dimension. So what? Energy is the derived. They are saying take as a fundamental. So energy dimension is what? ML2 T minus 2. Okay. So what I said, which derived quantity they are saying to take as fundamental? First write their dimension. Second derived quantity what? V they are saying take as fundamental, then LT minus 1. These two derived quantity we are taking as fundamental. Okay. T already fundamental they given. Now if you see these two equation, in that E is fundamental. So E I have to keep. I have to write in the terms of E. V I required. T I required. Which two are the like here? Which two are the derived? M and L. So I can find the value of M. I can find the value of L. Okay. So by using these two, basically I can say I have the two equation and I have the two variable. Which two variable? M and L. Because in the new system, M and L will be derived. So now I can find the both M and L by using these two equations. Here they are asking the M. So it means I have to eliminate the L. I will get the M. So by using these two, I need M. So I will eliminate L. I will get the M in the terms of EV and T. Okay. If I need the L, then I will eliminate the M. Okay. So what we will do here, I need M. Then here if you see, then you are getting L square. If L square you eliminate, then you will get the what? Dimension of M. In this L is there only. So what I can do? If I square it, so V square is equal to L square T minus 2. Suppose this is a 1, this is the 2. Okay. Now if you see, first contain the L square, second contain the L square. If you divide both, so E by V square. What I can write? M. Here L square cancel out, T minus 2 cancel out. Directly you got the dimension of M. So what is the dimension of M? I got the E V to the power minus 2. Everybody got or not? Completed? say yes or no. Okay. Method 3. Why it is useful? Because some question, like this year also they asked the question based on this method only. So method 3 means I can use this method for the different problem also. Okay. So that's why method 3 is also important, and mostly you will follow the method 3. But if this type of problem you can get by the 1, then it is the best. It will save your time. Okay. What is the method 3? Here I want to write the mass. I want to write the mass, and the fundamental I have to take what? Energy, velocity and time. Okay. So mass, how the mass depends upon the energy, what is the dimension of the energy in the mass, I don't know. Means maybe mass contain the E square, E to the power 1 by 2, E to the power minus 2, I don't know. Okay. They are saying write the mass in the terms of energy, velocity and time. But how, what is the power of the energy, what is the power of the velocity, I don't know. Then what we will do first, we will write what? Suppose E dimension, I am writing M dimension, I am writing as, I have to write in the terms of EVT. So E to the power A, where A is any variable. A is any variable. That A I don't know, because maybe M contain E square, M contain E to the power 1 by 2, M contain minus 1, E to the power minus 1, I don't know. So that's why I'm taking the variable A. Similarly, V to the power B and T to the power C. Okay, 3 quantities are there. I don't know how it depends upon the mass, depends upon the energy, inversely proportional to square, I don't know. So that's why I have taken the variable A, B and C. Okay. Now if I'm writing this equation, so from the homogeneity what I can say, left hand dimension must be equal to right hand dimension, because if I'm equating, so their dimension must be same. So what I can say, left hand dimension is what? LHD, left hand dimension is what? L0, or I can say M, L0, T0. Okay. What is the right hand dimension? So right hand, all dimension I will write. Energy dimension M, L2, T minus 2. Its power is what? A. L, then velocity. Velocity is what? LT minus 1 whole to the power B and T to the power C. Okay. Now what is the total M power I am getting? Total M power is what? M to the power, here A, that's it. Okay. L power what I am getting? Here 2A, here I am getting B. So A 2A plus B. Okay. And T, what is the total power I am getting? Minus 2A, here minus B plus C. This I got right hand dimension, M to the power A, L to the power 2A plus B and T to the power minus 2A minus B plus C. Okay. Now left hand dimension must be same as right hand dimension from the homogeneity. Okay, then what I can say, M to the power A here, and there M to the power 1. So A value what I got? 1. Then here L 2A plus B, and left hand side what is the L? 0. Okay. Now you can put the A value. A value is 1, then B what you got? Minus 2. So B value I got minus 2. Now third, minus 2A minus B plus C. That is equal to what? 0. Why? Left hand side time is 0. Minus 2A, so minus 2 into 1. Minus B means plus 2. Plus C is equal to 0. 2 minus 2 cancel out, C what I got? 0. It means T to the power 0. Now what is the dimension you got? Dimension M is equal to energy to the power A, so energy to the power 1, velocity to the power B minus 2, T to the power 0. So what is the dimension I got? EV minus 2. So any method, which method you are comfortable, you can follow. This you have to know, because some question we will do by using this method later in the application of dimension. Okay. Anybody has doubt? Okay. Okay. Now in the NEET, they asked one question very easily. You can say the answer. 2021 they asked this question: force, velocity, and time. V is what here? Velocity are fundamental. Then dimension of energy. Now you will say the answer. How fast you can say? F, force, velocity, and time we are taking as fundamental. What is the dimension of energy? FVT. Good. FVT. So very easily, first method we can use. We know that energy and work are equivalent in the terms of dimension, and work is equal to what? When you see the force, energy, then you have to relate what? Force and work. How I can relate? Then work is equal to force into displacement. Then energy I can say force into displacement, because I am dealing with a dimension. So dimensionally energy and work are same. So force into displacement. Displacement, what I can write? Next fundamental I will see velocity and time. So displacement is the velocity into time. So dimension of energy, what I got? Dimension of E is equal to FVT. Okay, so this question, same question you will try with the method 2 and method 3 also. At least you will get practice of the method 2, method 3 also. Is everybody getting or not? This we will say fast. If momentum P, velocity V, and time T are the fundamental, then what is the dimension of pressure? Then what is the dimension of pressure? So method 1 I will say, pressure, what is the formula? I'm using the letter small p because momentum they are using the capital P. Pressure is the basic formula, is the what? Force upon area. Neither the force is fundamental nor the area. In this problem, force is not the fundamental, area is not a fundamental. Now it means both I have to replace. Force and momentum. When force and momentum is force and momentum relation required, which formula will come in the mind? Newton's second law. Force is the rate of change of linear momentum, dp by dt. So means dimension of force, what I can write? P by T. P by T. Now P is fundamental, T is fundamental. Force problem over. Now only area is the problem. Only area is the problem. Area, what is the dimension? Area, we know that area is equal to L square. Okay. Now area is L square, then what I can write? Area L square. What is the L? I have to write in the terms of V and T. So L is equal to what? Vt. L is equal to what? Displacement is equal to velocity into time. So L I can write Vt, and V is fundamental, T is fundamental. Then area I can write as L square I can write as V square, T square. Then what I got? P upon V square into T cube. And now P is fundamental, V is fundamental, T is fundamental. Then answer what we got? P V to the power minus 2 T. Azan, what you are getting? This everybody got or not? So first method, what I said, if you are comfortable, like all the formula you can directly relate, then the first one is the best. It will save your time. But if you are unable to get from the method 1, then you have to go to the method 2 and 3. So this problem also you will try with the method 2 and 3. So P, V to the power minus 2, T to the power minus 3. Everybody got or not? Okay, so whatever the two problem I discussed, everybody will try with the method 2 and 3. At least you have to practice them, because if this does that method does not click in the mind, so you can go through the method. You can go through the method 2 or 3. Okay. One more I am giving. You will try. Next class I will discuss similar question. Momentum P, acceleration A, and velocity V are fundamental, then dimension of pressure. This also you will try. Next class I will discuss. Okay. Yes, I am learning from the PW. Yes, you are right. Physics PW. PW teacher has to join us. They will learn. Okay. Okay then. So all this you will try. Okay. Then we will discuss another type of problem. Okay then. Bye bye.